Hello, so this video is regarding the problem of the day on Geeks for Geeks. So today's problem is merge case sorted linked list. So in this video I will try to cover all the efficient approach to solve this particular problem. So all the approaches I have solved earlier, so I'm just trying to explain it in this video. So let's start with reading out the question. So merge case sorted linked list. So given case sorted linked list of different sizes, the task is to merge them in such a way that after merging, there will be a single sorted linked list. So as per question, so they are asking that sort the k sorted linked list in a single linked list. So okay, so I think so they have given an array in which every index of array consists of a linked list. So the size of the array is k. Okay, so the task is to complete the function merge k list, okay, which merges the k given list into a sorted one. The printing is done automatically by the driver. Okay, so the expected time complexity is n k log k. So n is the maximum size of the k linked list. So whichever the linked list have the maximum size, that is n, and k is the size of array, so k linked list. So we have to solve the inefficient way of the k n k log k, and the expected auxiliary space is k. So auxiliary space means so extra space we can take in this particular question to solve this particular problem. So let's start with the so let's start with the a bit of brute force approach. So I have created a sorted list variable and stored the address of the first linked list. So for first node of the first linked list. So okay, so I am running a loop for loop for k. So 1 to k means escaping the first one and working on the remaining one. So not start temp, so creating a temp variable. So it's the requirement up to requirement of the question. So whenever after the I discuss the approach, so all these variables are used in the particular solving this question. So temp variable, temp1 variable, L1 sorted list, and L2. So okay, so L1 is so currently the shortest list on each iteration. Shortest list is the sorted sorted list is a sorted linked list after the each iteration. So what I'm how I am moving in this particular problem is in this approach is that first I am picking this first linked list. So currently this is my sorted list. So now I am iterating on the remaining one. So I have sorted list currently this. So I'm now working on this one. So now how I am moving forward is that one pointer will be on my one. So first linked list, first node. So another pointer will be on the second jth linked list. If I say in terms of loop, so ith linked list, first node. So L1 and L2 are the first address of the both the linked list. So currently which I am traversing. So this while loop will run till the any of the linked list got empty or got iterated completely. So I have started the so first I am checking the data the value that particular node consists of. So if first node data is less than the second one, so and checking temp, yeah, so temp is the variable which will contain, which will so on each iteration I am creating a separate list from this two list. Okay, so currently a new linked list will be created separately which will store the smallest one, so in a sequential order. So if 1 and 4, so 1 is less than 4, so 1 will store in that particular new list. So iterator for this one will move to 3. Then we will compare 3 and 4, still 3 is less, so 3 will add to the new linked list. So I'm not creating a new node, just adding the address of this in the end of the current updated list. So in this way I'm proceeding for both the linked lists. So Okay, so 3 and 1 and 3 are added into new list. So I mean, which means we have came at the end of this particular loop. So after that I am checking, so is still any still linked list have remaining nodes or not. So if they are there, so I am adding them at the end of the temp. So temp is the which I said earlier, that temp is the new linked list current position. So that is the temp variable which is pointing to the current node. So after the temp I have added the linked list. So if L1, so in our case L1 is completely finished, so L2 is remaining, so L2 will add it at the end of the temp. And yeah, so shortage list is our answer which is updating on each iteration. So what is temp1? So let's go is variable. So temp1 is here. So whenever the we are creating a link new list, so temp1 is pointing to the first uh, first node of the particular updated list on this particular in this particular iteration. So uh, temp1 is there, we are storing temp1 to the sorted list. So on each iteration things are changing, right? So temp1 will point out to different one on each iteration. So we don't know that in the remaining particular column, so which one is the smallest one. So on each iteration, whenever the smallest one is coming, so it is joining at the first position. So in that way we are updating all the lists. So this loop will run from 1 to last linked list, and in that way we are adding the element in the new linked list and then updating the sorted list. So sorted list at the end, sorted list will be completed and we are returning it. So it's a brute force approach. So ideally what time complexity of this approach is, so k times this for loop is running, and under which this while loop is running for each of the linked lists. So k into, so L1 and L2, so they are running completely for both the lists, so not for only of one list. So whenever there is a okay, so in the worst case scenario, there is a chances the four or both the lists get iterated at the end. So if the size of both the linked lists is 3, and one by one we are moving in first in the first one, then in the second one. So ideally there is a chances that we will at the end of this while loop we will get iterated both the linked lists. So there is a pretty chance of that thing too. So in that case we are the size of n, the linked list is assuming that n the maximum size. So n into we are going n plus n to 2n. So this, so the complexity is k into n. So k into n is the time complexity. So okay, so this is not the brute force, but this is a efficient approach. So sorry for that in starting misleading the question. So this is the efficient approach. As we are running, we are the time complexity is coming after the we solved the question is that n into k. So n is the size of the array, the maximum size of the linked list, and k is the size of. So we are running k times and n the size of the linked list. So k into n is the and here we haven't used any access space. So we have just used a single variable. So they are constant. So and constant doesn't include as a linear time complexity. So or space complexity. So the sizes, so both the things are linear. So n into k is the efficient approach. So I have ran this question. So let me show you. So we are good to run, or we can say submit this question. So task is running. So this is showing that 0.6 is the total time taken by this particular approach. So in the next approach I will show you time complexity and both the thing. So this is the one approach. So earlier I told that it's the brute force one, but it is not. And Now we are moving with the required approach. We can say that up to what question mentioned that you have to do the question in this particular time complexity and space complexity, so that approach is the appropriate one. So the thing is that appropriate one is that this concept which is used in this particular approach, which I am going to tell you. So the thing is that let's observe the time complexity they required, so they are wanting. So by analyzing the time complexity, we get to know, okay, so which data structure we should use in this one. So the thing is that they are want n k log k. So k log k means that as the question stated that sorted, so sorting itself is a hint in this question. So and k log k means merge sort, quick sort, those algorithms are in the ideal case give k log k time complexity or logarithm time complexity. But as we are working on the linked list, so we can't use merge sort and quick sort and linked list in that ideal case. So we have to use some data structure that we get to know about the space complexity. So O of k, so k means the size of the array, so we can use that much of space in our question. So other than the sorting algorithms, we have a data structure which can give us which can give us the ascending order or descending order, or the smallest element or the largest element. So there is a concept of heap, which min heap and max heap, which means that min heap is the topmost element of that heap is the smallest one in the all the heap, and the max heap means that the topmost element is the largest one in that heap. So to implement that particular concept of max and min heap, we have a data structure that is called priority queue. So in this particular question, we are going to use the priority queue, so which is also the requirement of the interviewer in whatsoever interview got to face this question. So they want that you should solve this question with the help of priority queue, because they want to know that they want to know that the other guy know the concept of priority queue or not. So in that way, so we are using a priority queue. So as there is a node, so priority queue you can use the int type, but in this case the requirement of this question is that we have to use a priority queue of linked list node data structure. So node data structure is here. It is in the form by using structure concept. We have used they have created their own data type, so that is node. So we are creating a priority queue of that particular data type only. And so now the requirement is that ascending order we have to print, or sorted. So sorted means ascending order, they want to be the linked list in the end. So we need to use a min heap. So the syntax of the min heap is in this way. So node star you can replace node star with any data type like float, int, any, and vector node star, and this is a particular syntax which they follow. So as we are creating our own data type, so we have to create a function which this priority queue recognize to compare two values, and accordingly they will put down the values in the heap. So so for that we have the way of to create this function is that we have to create a separate structure, the name of the structure, and in the end of the parameter we are passing has to be same, and inside that particular structure we have to create an operator function in which we are passing two parameter of that particular data type which you are mentioning here, in which you are comparing accordingly. So you can manipulate this particular concept up to your use. So in this way you can change the concept. So if someone wants to do a max heap, so you can change the condition here. So in that way you can go, but max heap you don't require to manipulate that thing. But as node star is there, so priority queue has to know that you have to compare on basis of data or whatsoever. So just passing the data type is not a appropriate way. So we have created a priority queue which is using using the concept of min heap. Then we required a sorted list which we are going to return in the end. So there is, we have created a variable current. So let's proceed, and then we got to know about where we use current variable. So this loop will run, and it is adding the all the first addresses of the particular array. So how we are going here is that we are adding the address of 148 in the priority queue. So okay, so we have added 148 address. So how this compare function is working? So first we have added 1, so there is no function to compare, sorry, variable. Then we have added 4, so it is comparing 1 and 4 though with the help of address. So we are comparing the data of 1 and 4, so whichever will be the smaller one, it is going to be in the at the high level of the min heap. So 1 is at the top, then 4, then we are adding 8, then accordingly 8 will compare with 1, so it will go the lower side, and then we have a heap of 1, and in the lower side we have a 4 and 8. Sorry, yeah, I should have used some blackboard kind of thing to explain this particular approach, but sure, next time I will use that thing. So here we have in this way we are adding the particular value in heap. So heap is ready with the first addresses of the first column of our particular array list. So after that we are running a while loop. So while loop will run till the min heap got empty. Okay, so first we are storing the topmost value in a variable. Then if the shortage list that the answer or the pointer which we are going to return is empty, means there is no element in the list currently, then we are storing the address of the topmost element in the shortage list and the current. So current is the pointer which will go forward in our answer in the shortage list. So shortage is going to be our answer. So current is the will show the position of the current node in the end, that is. So that is the use case of current variable. So if there is no element, then current and shortage list will be pointed out to that particular first element of the list. If there are any, then we are storing the address of the incoming element in the next of the current, and then then moving the current one step ahead. So in this way we are getting a sorted list. So then we are popping out the particular element from the priority queue and adding the new element. So if heap to next, so heap top to next means so the current smallest element is taken away from the list, so we need another element which is in the list after that particular element. So suppose we have added the 5 and 5 is popped out, so we have to push 6 in the heap. So that is the same thing which we are doing here. So we are pushing the 5 next to 5, that is 6 in the heap, and then making 5 after null. So that is the current position to after. So the answer sorted list the and last node to next is going to be null, because we don't need the suppose that 5 is pointing to 6 and 6 is pointing to someone, so we don't need that particular list to be added in the in our answer list. So in this way we are adding the elements in the end and we are getting the sorted list. So that's what the also the requirement of the question in terms of prime complexity and auxiliary space. So let's compile this approach and let's see what time it will take. So as you can see 0.7 and the last approach took 0.6. So there is a bit of more time this approach took, but as the requirement of question is to use the concept of priority queue, so we have used that. So there might be a I don't say that I have shown the efficient one, but there might be a efficient one, but up to my knowledge, so these are the two approaches which I can figure out for this particular question. So thank you if you have watched the video till now.